On number 1, if you risk nothing, then you risk everything. Do we have a signal word to tell us what our hypothesis is? If is our signal word. Everything that comes after the if is my hypothesis. So what is the hypothesis on number 1? Yep. Everything that comes after this is our hypothesis. Remember, when we write out the hypothesis, it should be a complete sentence all on its own, which is why I don't include that word if with it. Because if I say, if you risk nothing, it's not a full sentence. You risk nothing would be my hypothesis. You need to put that away and leave it put away. All right, you risk nothing as my hypothesis. What is the conclusion then? You risk everything. We have another signal word, then. Everything that comes after that is our conclusion. On number 2, do we have a signal word for our hypothesis? Do we have an if? Yes. Where is it? Yeah, it's after accomplish. It's here in the middle of our sentence. So here's my signal word to tell me that everything that comes after it is the hypothesis. So what would my hypothesis be? You do not care who gets the credit. Here's our hypothesis. What is our conclusion then? It is amazing what you can accomplish. There's our conclusion. All right, go ahead and pull your books out for me. The little bit that we need to finish up in your book. Page 165 is where we're going to pick up. This is where we left off on Friday. We had just started talking about biconditional statements. And we had done the first part of example 6. We took the statement, Rasha listens to music when she's in study hall, and we wrote it as a conditional. If Rasha is in study hall, then she is listening to music. That's true. If Rasha is listening to music, then she is in study hall, which is false, because she could be at home, or she could be in the lunchroom, or she could be in one of her other classes. Both the conditional and the converse have to be true in order for us to write this as a biconditional statement, an if and only if statement. So I want to practice doing something like that again on part B. Here we have, if 2 lines are parallel, then they have the same slope. When I write a conditional means I'm going to write an if, then statement. Do I need to change anything about the statement to turn it into an if-then? Nope. They already wrote it in if-then form, so let's recopy that down here. If 2 lines are parallel, then they have the same slope. I want to evaluate whether that's true or false. I want you guys to think back to your Algebra 1 class and anywhere else that you might have run into these words before. What do parallel lines look like? Yeah, they can look like this, or like this, or like this. Are they ever going to get closer together? Are they ever going to touch each other? No. So never get closer together, never going to touch each other. They stay the same distance apart, always. What is slope? From Algebra 1, what do you guys remember slope is? Rise over run. Slope is rise over run. It's describing how we move to get to the next point. If I have this line, and it has a y-intercept of, say, 3, and then I have a rise over run, up 2, right 1, up 2, right 1. And then I have another line, looks just like this one, up 2, right 1, up 2, right 1, up 2, right 1, but it starts at a different place, a different y-intercept. Because they're moving the same way to get to the next point, they're never going to get closer together, they're never going to get farther apart. Because I would go up 2, right 1 on both lines, but I'd be in different places. Up 2, right 1, up 2, right 1. We're never going to get closer together, they're never going to intersect. Do you guys think this conditional statement is true or false? If two lines are parallel, this is true, then they have the same slope. What do I do to a statement to write the converse? Let's see who remembers this from Friday. Yes. We flip. We're going to switch the hypothesis and the conclusion. So my original statement was, if two lines are parallel, then they have the same slope. How would I take that and switch my hypothesis and my conclusion? Yes. Instead of using my pronoun they at the beginning, I'm going to say if two lines have the same slope, then they are parallel. When you write yours, if you said if they have the same slope, then two lines are parallel, that would have the exact same meaning, and I would count that for full credit on the converse. What do you guys think? Is that one true or false? If two lines have the same slope, up 2, right 1, up 2, right 1, up 2, right 1, then they're parallel. They're never going to touch each other, and they're never going to get closer together. That is true. So because the conditional and the converse are both true, a biconditional can be written. In a biconditional statement, I'm going to take my hypothesis. Two lines are parallel. Notice I don't put an if at the beginning when I'm writing my biconditional. I just start off with that first statement with the hypothesis. And then what makes it a biconditional is this piece right here. If and only if. So two lines are parallel. If and only if. What was the other part? What was the conclusion up here? They have the same slope. Two lines are parallel if and only if they have the same slope. Go ahead and turn the page over to 166. We're going to try to do this again. So we have the statement, isosceles triangles have at least two congruent sides. I need to turn this into an if-then statement. So I would say if what? Yes. So if a triangle is isosceles, then it has at least two congruent sides. I'm going to abbreviate a little bit for space. So there's my conditional. Is that true or false? That is true. Now I want to write the converse. What do I have to do to write the converse? How do we do that? Switch. We're going to switch the hypothesis and the conclusion. So instead of if a triangle is isosceles, this is going to be if what? Yes, if a triangle has two congruent sides, then what? Yep, then it is an isosceles triangle, or then it is isosceles. Is that true or false? That is true. The conditional is true. The converse is true. So we can write a biconditional. How would my biconditional statement start? Remember, I don't use if or then on this one. Yes, a triangle is isosceles if and only if it has two congruent sides. Right. I want to take this idea of a biconditional statement, starting with a conditional, writing the converse, evaluating if they're both true. So can I write it as a biconditional? I want to reverse that process now. Down in example number 7, we have a biconditional. I want to write it as a conditional and as the converse, and I want to evaluate whether both of those are true to see if that biconditional statement is true. All right, so our biconditional statement, two angles are complements if and only if their measures have a sum of 90 degrees. So what would my conditional statement be? Remember, conditional statements start with if. Yep. If two angles are complements, yes, then their measures have a sum of 90 degrees. Is that true or false? When we say two angles are complements, we say they're complementary. That's another way of wording that. So if two angles are complementary, if they're complements of each other, then their measures have a sum of 90 degrees. Is that true or is that false? That is true. All right, now I want to write the converse. So we're going to switch the hypothesis and the conclusion. So instead of if two angles are complementary, we would say what? If two angles measures have a sum of 90 degrees, yes. Then they are complementary. Is that true or false? That is true. If both the conditional and the complement are true, what does that mean about the biconditional? It's true. Conditional and converse are true, so the biconditional is true. All right, let's do the check down at the bottom of the page. I want you guys to take just a moment to write the conditional statement and then write the converse. And then we'll talk about whether they are true or false. Write the check down at the very bottom. You're welcome. Conditionals have to start with what word? If. So this would be if what? If x is greater than -2, what would come after that? Then x is positive. For my converse, we have to switch the hypothesis and the conclusion. So this would be if what? If x is positive, then x is greater than -2. All right, I want to evaluate the truth of each of those statements. So here's 0 on my number line. Here's -2. In order for something to be greater than, it needs to be further to the right on the number line. So if x is greater than -2, if x is farther to the right on the number line, then it has to be a positive number. Is that true or false? That is false. Why? What else could x be? X could be -1 right here. -1 is greater than -2, but -1 is not positive. What about the second statement? If x is positive, then x would have to be greater than -2. That one's true. Can my biconditional be true if one is true and one is false? No, so we would say our biconditional is false. And then we're going to give a counterexample, which you guys did right up here. Biconditional is false because -1 is greater than -2. And -1 is not positive. right. That finishes off what we're going to do in your book for today. Everything that we covered Thursday, Friday, and today is on that homework that is due tomorrow. This one doesn't say 3-2 homework because that didn't print for some reason. It says statements, conditionals, and biconditionals. This is the homework due for tomorrow. If you don't have a copy of this, I've got lots of extras up here. Just make sure you come and ask me for that. For the rest of our time together today, we're going to be in this stapled packet that says 3-4 notes, writing proofs. And at the same time, you're going to need this golden piece of paper out. This has the reasons that we're going to be using on these notes. So please have both of these out side by side. The side that I want you guys to have face up on the golden piece of paper, up at the very top, it says given. This is the side that I want you looking at right now. So the side that says given should be the side that you have face up. When we write proofs, we walk through the steps of solving a problem, and then on the other side, we say why we're allowed to make that step. So I want to look at an algebraic problem first before we look at a geometry problem. And we're going to try to determine why we're allowed to take each of those steps. The first step in my proof is always going to be given. That's the thing, that's the starting place that I was asked to start at. So -10 parentheses 3x minus 6 equals 4x plus 2. This is my given. This is our starting place. What happened between that very first line and the next line down? What did the person solving this problem do? They distributed. So I want you to look at that yellow piece of paper. Why are we allowed to do that? What property or definition allows us to do that? Distributive property. All right, so now I'm going to look at the second line and compare that to the third line. What changed between the second line and the third line? What's different? What about x? They added 30x to both sides. That's how they got this 34x here, and that's why this piece canceled out. So what allows us to add 30x to both sides? Addition, property of equality. Okay, so now I want to compare the third line with the fourth line to go from 60 equals 34x plus 2, and on the next line down they have 58 equals 34x. What did they do? They subtracted 2 from each side. Why are they allowed to do that? Subtraction, property of equality. All of my properties of equality, this is in Algebra 1 when you guys say if you do it to one side, you have to do it to the other side. That means it's a property of equality. And then we've got this piece where I have 58 over 34. How did they get 58 over 34 and then they have just this x over here? They used division. So what property is that? Division, property of equality. And right here in the middle, where they have 29 over 17, what they did was they took 58 over 34 and they reduced the top and bottom by 2. That's how they got, sorry, not 34, 29 over 17. So they reduced there, which is still considered to be division property of equality. All right, this last one, here we had 58 over 34, which is the same thing as 29 over 17 equals x. And on the next line down, I have pretty much the same thing, except where's the x now? Is x still on the rightmost side? No, it's been switched to the left side. And 29 over 17 is now on the right-hand side. I want you to look carefully on that yellow piece of paper, the side that starts with given. What is it that allows me to take an equation? This piece is on the left, this piece is on the right. I'm going to keep all those parts the same, except I'm going to switch them to opposite sides of the equal sign. What property allows me to do that? Be symmetric. This is the symmetric property. Reflexive property seems like kind of a silly one, but it ends up being important later on. Reflexive property says something is equal to itself. So like x equals x, 5 equals 5, 2y equals 2y. If you have something equaling itself, that's our reflexive property. I want to look down at number 2 now. There's a whole bunch of parts in boxes. We're just going to figure out what property would allow us to make the second part of the statement. So we're starting with the idea that the if part is true. So on part A, the distance from Q to R is the same as the distance from S to T. Those distances are exactly the same. And then in the next line down, I have QR plus BC equals ST plus BC. Well, the QR stayed over here on the left. ST stayed on the right. But what have we included on both sides now? ST. What's happening with the ST on both sides? What operation is occurring? Addition. We're adding BC here. We're adding BC here. What property allows me to add the same thing to both sides? Addition property of equality. If you need to abbreviate for space, you can abbreviate prop instead of property. Instead of writing out the whole word equality, if you put an equal sign, that would be fine. In part B here, I have the measurement of angle ABC is equal to the measurement of angle KMR. And in the next line down, KMR has now switched to the left side, and ABC has switched to the right side. What property was it that allows me to take the left and right side and just flip them around? Symmetric property. We discussed this just a moment ago. Here I have that the length of segment AX is equal to the length of segment AX. What allows me to say that something is equal to itself? Reflexive property. All right, next one down. Let's look at D. On part D, I'm told at the beginning that the measurement of angle 1 is the same as the measurement of angle 2. And then I'm told that the measurement of angle 2 is the same as the measurement of angle 3. So what would allow me to make the jump to say that angle 1 is equal to angle 3? I heard transitive property. There's another property that I could use here too. We can do transitive. What other property could I use here? So transitive property is specifically when I'm looking at one thing. I know that one thing is the same as the other. I weigh the same as my mom. And then later on in the conversation, we find out that these other two things are equal. My mom weighs the same as my sister. So if I weigh the same as my mom, and my mom weighs the same as my sister, that means I weigh the same as who else? I weigh the same as my sister. That's what the transitive property allows me to say. There's another property that I could use here that allows me to take things of equal value and use them as replacements. Substitution property. So we could call this one the transitive property, or we could say this is the substitution property. Part E. We're starting off with the idea that 2 times the measure of angle 1 is the same size as the measure of angle 2. So if I take this one and I double it, I get this one over here. That's where I'm starting from. What property could I use then to make this next step where I say the measurement of angle 1 would then be half of the measurement of angle 2? How would I make this 2 right here cancel out? Division property. Division property of equality. Because I would divide both sides by 2. Part F, I have JK plus AB equals RQ plus AB. That's the place that I'm starting at. What would allow me to get rid of the AB on both sides? I still have JK here, I still have RQ here, but I've gotten rid of AB in both spots. Subtraction property. Of equality. Just a couple more on this side before we get to turn the page. Down at the bottom, I'm starting off with 2 true statements. AB plus BC equals AC. And then they tell me that BC and DE are the same size. What's different about this bottom statement than the one that I have a blue box around? What changed? BC got replaced with what? DE. Well, what do we know about BC and DE? They're equal, they're the same. So why am I allowed to take BC out and put something of equal value, DE, in? Substitution property. Part H, angle 1 is equal to half of angle 2. So why would I be allowed to make this statement down here that 2 times the measure of angle 1 is equal to angle 2? What happened to both sides? multiplication property, because 2 times 1/2, that will cancel out. This is our multiplication property of equality. All right, flip it over. We're going to do 1 at the very top, and then we're going to stop. All right, so I start off with this first statement. Measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 150 degrees. And then they tell me that the measure of angle 3 is equal to the measure of angle ATE. Why would I then be allowed to make this statement back here that angle 1 plus angle 2 plus ATE equals 150 degrees? Substitution. We took angle 3 out. We put something of equal value in its place, ATE. So that would be the substitution property. All right. We're going to stop right there for today. What is due tomorrow? Homework. It does not say 3-2 homework up at the top. It says conditionals. Sorry, it says statements, conditionals, and biconditionals. Statements, conditionals, and biconditionals homework is due tomorrow. When you come in tomorrow, you'll pick up the next homework, and we'll talk about that due date. You're going to want to use that golden piece of paper to help you with our next homework assignment, because that has all of our reasons on it that we're going to be able to use.